So Jackie typed into the chat that the top increased by 2s while the bottom increased by 5s. Amanda Ball talked about the pattern she did multiplied by 10s. Mike Thomas says the numerator and the denominator are doubled, multiplied by 2. Whatever you do to the numerator, you do to the denominator. The denominators are multiples of 5, lots of doubles. Some people saw 10s. Numerators are evens, the denominators are multiples of 5s, right? Some different ways of describing that pattern. As long as you multiply by 1, there are infinite possibilities. Meredith, would you unmute your mic and talk to us about that a little bit? Because you are correct, but I love the way you phrase that.
I'm sure it's a KCM thing, I'm training or whatever. You know, I always, as a 5th grade teacher and teaching those, the equivalent fractions, it makes me insane when the kids say multiply by 2. I'm like, you don't multiply by 2. If I multiply that by 2, I'm going to get 4, 4/5.
4/5.
And
yeah.
so I always make sure that they say I have to multiply by 1. And I've come up with a strategy to make sure that they do that. And so they will get it. So when you said whatever you do to the numerator, you do to the denominator, well, if I make like a 1 out of a box and I put a fraction bar in it and I put 2 halves, 3/3, 4/4, and I show them, those are just all the ways to say 1. 1 is not just the way we've seen it on the number line since 1st grade, kindergarten, but anyway, and it's funny because I have to tell this little vignette. I had a little girl at the end of the year. She made me some little paperweight for my desk and she put a 1 in it with a fraction inside. She was the #1 teacher and she put a fraction inside. I was like,
great.
This forever. So there's my thing.
Very cool. Very cool. Mindy also had typed into the chat about each step, like 2/5 would be step 1 and the greatest common factor would be 1. Step 2, 4/10, the greatest common factor would be 2, and so on. So we can pull a lot of different math, right, out of this one activity, right? So this activity can be useful from intermediate on up into middle school because you can pull out, because some of you were pulling out integer work, you can pull out all sorts of different things in here to revisit skills from earlier and also add on from things that, build from what students already know on board, or just to see what they do have on board already. Okay, that cute, Kelly, yes. All of us are #1, no matter how you write that #1. I love that. Super cool. All right, ready for the next slide, Bethany? So one of the things I want to make sure to highlight, and some of you have seen this in some courses with us from KCM, but for many of you, this is going to be new. And one of the things that we highlight in some of our coursework is this development of mathematical reasoning. And I love to have a room full, Zoom room in this case, of folks from lots of grade levels together, because I really like it when you can see how the work that you all are doing builds on each other as we go along the way. And so I always like for you guys to be able to see that. And so kids start with counting strategies in early primary and then go into additive thinking still in early primary. And then that builds into multiplicative reasoning. And you'll see that they're inclusive of each other along the way, right? For different skills, we still go back and use counting strategies even as an adult. And as kids are learning additive thinking, they're still using counting strategies. And as they learn multiplicative reasoning, they're still using additive thinking. These things build on each other. And one of the things that's really important for us to know is that kids don't get to proportional reasoning. Kids don't learn to be proportional reasoning human beings until they actually understand counting, adding, subtracting, multiplying, and dividing. We can't shortcut that development, right? Those things they're learned from each other, they build on each other. And then we don't get into functional reasoning, right? Unless we've actually attained proportional reasoning. You use those skills in actually working with the things you need to know in algebra, right? We cannot shortcut that. And the whole thing of this is reasoning. This is students doing the work, students doing the thinking. But one of the things I want to highlight is that spatial reasoning and algebraic reasoning are developing together throughout this entire process, right? They are built into this entire process, and all of the things that happen along the way, from counting through additive, through multiplicative, through proportional, into functional reasoning, those things that we build along the way with our students, the experiences we give them are where they're also building their spatial reasoning and their algebraic reasoning, right? So all the work that you're doing at every grade level along the way is super important into making that happen. The good news, if you'll go to the next slide, Bethany, is that our standards, the way that they come to us in the state of Kentucky, and they really were this way before, is they are built to build on each other, right? They are designed with that trajectory of reasoning development in mind, right? Because we spend time in primary doing counting and spending lots of time doing that well and going on and so forth and so on. So this particular trajectory you see here is a trajectory that leads us to the activity that we asked you guys to engage with this month of October, and that we're going to spend some time revisiting tonight. The arrows are pointing specifically to the standards that the activity itself is designed to address, which are an 8th grade standard and some high school standards. But what I want you to know is along the way, you used or will use skills that go all the way back to earlier elementary, right? So to do that activity, right, an 8th grade student or a high school student would have needed the skills from the 3rd grade standard of flexibly modeling and representing multiplication and division situations, being able to make multiplicative comparisons, right? How many times something is as much, for instance, right? Interpret fractions as division, describe ratios as comparisons between related quantities, right? Understanding unit rates, recognizing and representing proportional relationships. And then we get to 8th grade, right? And that's the standard that we start engaging in this activity. But what I think that it's fascinating to me, and primary folks, it actually really starts with, this is part of why we started with that fraction activity while we were waiting for folks to get in, because it really starts with seeing doubles, right? Being able to see doubles, I'm flashing 2 and 2, and it's a big deal that we understand that that makes 4 and that's doubles. And so even going back to primary, some of those things are important for building the relationships along the way that make what seems like higher level math, right, really immensely doable. Okay, so let's dig in a little deeper to the standards that go with our activity.
Okay, so first, let me just introduce myself. My name is Bethany Noblitt. I'm a professor in the Department of Mathematics and Statistics at NKU. And I just want to say thank you for having me here tonight. It's really exciting to be part of such a big group of Kentucky math teachers who are just who want to spend time thinking about mathematics and thinking about working with students in the best way that you can. So anyway, I'm just honored to be here, and I appreciate you being here tonight. So like Dee was saying, we're going to look at these standards specifically and how they relate to the activity that you all worked on the past few weeks. So just to bring out those standards a little bit more specifically, the 8th grade standard is one that brings out certain characteristics of rotations, reflections, and translations of the 3 transformations that you all looked at in the activity that you worked on the past few weeks. And the first part of the activity, which we're not going to talk too much about tonight, really brought out these congruences that you see on the screen right now. And you probably used GeoGebra to explore the transformations and to notice these different congruences. Angles being congruent to angles, line segments being congruent to line segments. So that was the first part of the activity that you really kind of just played around with GeoGebra with. And then the first high school standard is representing transformations. You did that plenty. We could talk about thinking about transformations as functions. I will tell you, you know, as part of what you did the past few weeks was you also watched some videos of my students working through this activity. You just saw 2 little clips. This was quite an intensive activity, if that's the right word. So they worked for quite a while on it. So we had lots of video, and part of what they did was really dig deep into how these transformations can be thought of as functions. And that's really a nice connection for students to make, to take something that they really see as geometry, right? Like they sometimes they tend to put these things in silos, right? So they take something they see as geometry and relate it to the idea of functions. That was a beautiful conversation, and I'm sorry you didn't get to see video of that, but also in this standard, we really just explore transformations a little bit more, explore what how a pre-image and the image under a transformation are related. Then this final high school standard, the G3 standard, this is really like the heart of this activity, in my opinion. This is like the end, the payoff, the big moment is when these students wrote definitions. They actually developed their own formal definitions for the different transformations. I hope that you all were able to watch the video, because I think there were some beautiful moments in those videos. This standard is actually the one we're gonna talk a lot about tonight. But also wanted to bring to your attention the standard for mathematical practice, attend to precision, because I think that this activity really taps into that standard as well. Especially the part here where it says they use clear definitions in their discussions. So in these discussions that you saw the videos of, I mean, the students were trying to write their own definitions. So they were really trying to clarify those definitions on their own. And, you know, it goes on to mention carefully formulated explanations. And also the last line is making explicit use of definitions. So communicating precisely in this use of definition is really key to this standard for mathematical practice. And I think that comes out in this activity. So those are the standards that the transformations activity that you worked on address. The first, actually, let me think about that. Part 1 of the activity, there was a part 0, and then there was a part 1 that dealt with translations. You were given 2 figures, and
he said, "Don't mess with me. I'll start."
Oh, sorry. I thought maybe it was somebody. The first part of the activity, you were given 2 figures, and you were asked to connect. You were told that this was represented a translation, and you were asked to connect corresponding points of the pre-image and the image. So the pre-image is this A, B, C, D, E image, and the image is this A prime, B prime, C prime, D prime, E prime figure. I should have said figure there. And so you were asked to connect corresponding points of those figures, when you did that, it might have looked something like this. And then you were just asked to make some observations. What do you notice? So if you could maybe take just a few seconds and type what observations you noticed when you made these connections, when you connected the corresponding points. Type that in the chat box, and we'll maybe point out some of those observations before we move forward. As you're typing, the goal of connecting the corresponding points was to start to develop or start to make observations that would lead to a definition for a translation. So I'm seeing some in the chats, I'm seeing some parallel lines. I'm sorry, you all, chats are so hard for me to follow. I'm not very good at keeping up, but I see parallel lines. I see some people said it looks like like it kind of makes it look like a 3D figure, which it does. But yeah, I'm seeing lots of parallel lines. Yeah, and that's really one of the big things that my students noticed as well when they worked through this. That was their number one observation as well. Thank you for the comments in the chat box. So based on those observations, what you were asked to do earlier and what my students were asked to do was to use those observations that to write a definition for a translation. And I got them started by giving them 3 words, but it was really amazing how just those first 3 words kind of served as a bridge between their observations and them actually writing a definition. So what I prompted them to start by writing their definition. Translations move points. And then I had them finish that statement. So maybe you worked through this a few weeks ago, I don't know, a couple weeks ago, and you have a definition, or maybe you're just looking at it now and kind of thinking based on those observations, what your definition might be. So again, I'll prompt you, if you don't mind, take a couple seconds and type in the chat box what your definition might be for a translation. And it should start, translations move points, how? So take a moment and maybe type in a definition for translation in the chat box. While you're doing that, I'll tell you, when I had my students doing this, you know, there were 4, I think I had 4 students working on this together. You saw the videos, 3 or 4, and you know, they had a lot of conversation about this. So sometimes it takes a few minutes to kind of think through. Well, of course, translations move points in the same direction, the same distance, sliding them the same distance. I'm seeing sliding them. Move points left or right, horizontally, as if sliding. We use that word sliding when we talked about it with my students, for sure. Same distance, same direction. Yeah. Now here's something kind of interesting. So when you made the observations on the previous slide about the lines being parallel, I'm curious if anybody had use the idea of parallel lines in their definition. Did anybody use the idea of parallel lines in your definition? That was like one of the first things you noticed. So I'm curious. Yeah.
Me too. Because I was looking for that word and it's not in anybody's so far. Yeah.
Yeah. It takes too many L's to say parallelly. Yeah. It moves figures parallelly, right? Yeah. Well, I'll just leave that question kind of hanging there, because I think you're gonna see that play out when we watch the video. And maybe you've seen the video before, but it's just a couple of minutes, and probably if you watched it, it was a couple of weeks ago. So it will remind you of what my students did when they were doing the same activity. So I'm going to play this video. You'll see my students. And let me just say, I told you that it was really an honor to be here tonight. And I truly mean that. I get to do two of my favorite things. One, which is talk about like kind of some neat math that I like to talk about. But also I get to kind of brag on my students because they're so awesome. And these students were just really cool about doing this this activity with me, and so I just love them so much. I want to give a thank you to them before you watch the video. So here's the video. Now what you're going to see is them after they made their observations, and they're working together to try to write a definition for translation. So I hope this works okay.
So, I mean, if we just look at a picture that we have, these points pretty much just moved across these parallel lines.
Yeah.
And then they all moved the exact same distance across those parallel lines.
No, I agree with that.
So if we wanted to put that into a sentence, I mean, we could say,
Move points across parallel lines with exact distance and direction. Naming vectors or whatever.
Yeah, and those are the vectors that you were talking about, right? Yeah, good.
and move points across parallel lines.
With same direction and distance.
So I hope you could hear that okay. Could you hear that okay? I'm seeing some yes, great. So that was just a brief clip of their conversation about their own understanding of the definition for translation. So I clipped out their definition that they wrote on the board because I know it was hard to see in the video. You can see it on the screen right now. So what I want you to think about is, first of all, which is not even up here, just your own experience with the activity and thinking about the definition, even if it was just these last couple of minutes that you've spent doing that just now. But also I want you to read the student's definition, think about how the students talked about it, and think about how that compared to your definition or even the definitions that we see in the chat box right now. I'm going to give you a little, so in a moment, you're going to go into breakout rooms to do this. I want to give you one little extra challenge, okay? Here's an extra challenge. So in the video, Simona, she was the student who was at the board writing. She verbalized the definition, and there is actually a difference in what she said and what's on this screen right now. There's a word that she used that is actually not in here. See if you notice what that was. That's tricky because if you weren't really paying, I know that's probably an unfair question, but I'm gonna bring it up again later. That's why I'm mentioning it now. So we're gonna go into breakout rooms, talk about the definition. You're thinking about the definition, the students thinking about the definition. We'll spend about 5 or 6-ish minutes in the breakout rooms, and then we'll come back and talk more. So enjoy. All right. I think we're back. I think we're all back. I do hear somebody like something's playing in the background, so you might want to mute yourself just so I don't know, for obvious reasons. Okay, so thank you so much for talking about that. I visited one group, and as soon as I went into that group, I heard a conversation about that challenge that I gave you. The challenge I gave you being, what word did Simona say when she was talking about the definition? But then I put this definition written up on the PowerPoint here that you're looking at, and there's been a change. There's been a change in the wording. And the group that I was in, they were talking about that. I mean, I thought it was a challenge, but you all are listening really close. So gosh, thank you for your extra awesome attention to detail. Let me ask if you don't mind, Julie, can I just ask you to share what you noticed?
What I heard her say was, I thought I heard her say the word across, and she had written the word along.
Yeah.
So that was I thought that was a difference and then we had a discussion about how that came about how you pulled that language out in another way, which was really to make them think about changing their wording.
Yeah. So if I could connect this back momentarily to that standard for mathematical practice, attend to precision, right? I think this is a really great example of attending to precision, because Simona, when she was talking, she said the points move across a line. Yeah. And I understood what she was saying, because I think she was even like using her hand, right? Like across the line and yeah, right. And if you notice, one of the other students, she was like, kind of moving her hand. So I know what they were saying. And so when they first wrote it, they wrote translations move points across parallel lines with same distance and direction. Okay, fine. We moved on. The next thing we did, now listen to this part of the story is interesting. The next thing we did, the next transformation we did was reflection. And you know what word they wanted to use for reflection? Across a line of reflection. And in that moment, I had to ask them, you're using the word across when you're talking about a reflection, and you also use the word across in this definition for translation, and the motions feel very different to me, right? So where do you want to use the word across, and how will you change it, right? Just in the other definition for it to make sense. And so we had a conversation about the word along versus the word, about the word across. And then they came up with the word along for translation. It was a wonderful conversation. And this all to me, this was an exercise in precision, right? Yes, it was an exercise in transformations and translation specifically, but it was an exercise in precision as well. And it was really, really a nice conversation. Okay, so I hope that you enjoyed your breakout room conversations. Let's move on.
Need to reshare your screen.
Oh, I am so sorry.
I knew you were talking about something they didn't need to see, but they were going to need to see the next thing. Yeah.
It's just like my students, Oh my gosh, they have to tell me every now and then, we don't see what you're talking about. Okay, yeah. My apologies. Okay, thank you for that. Now, when we did this activity and when you did this activity, the next transformation that you explored was the reflection. It's beautiful, it's wonderful, lots of good things to talk about. We're not going to talk about reflection tonight because we simply just don't have time. And I thought that the rotation would be a good one for us to talk about because, well, there's just a lot to it. There's a lot happening with rotations. So in the activity that you completed, as well as what the students did, they were given two figures. Now, I'll tell you something different about when the students did this activity. I didn't tell them this was a rotation. When you all did the activity, I told you it was a rotation. And I did that just because you weren't working in the context of our group. It was just a different environment in a different context. They had to decide that this was a rotation. And then once they decided it was a rotation, then we proceeded. I asked them to connect corresponding points to what they had determined to be the center of rotation. And then I asked them to construct circles. So they connected like C to the center of rotation and C prime to the center of rotation. If you can see, I don't know if you can tell the colors real well, but those are the blue lines on my screen. And then the red lines, corresponding points to the center of rotation. And then I asked them to construct circles, and I asked you, I guess, to construct circles centered at P that have radii PA, PB, PC, so on. So you have all these circles. First of all, let's just stop and say, what a lovely picture to look at. Oh my goodness, there's so much going on here I can think about and look at and talk about. Oh my gosh, beautiful picture. So then I asked them the same question. And I ask you this question. Just what do you notice? Can you take a couple seconds here and type in your chat box just any observations you have? It's wide open. Whatever observations you have, send me a chat or send the group a chat. Okay, so I'm seeing some right angles. Visuals are powerful. You know, I have a lot of students who say, well, I'm a visual learner. I'm a visual learner. I think we're all visual learners, really. Spinning, looks like it's spinning around a circle. The letters are the same place on the circle. That's interesting. Probably lots of good questions I could ask about that. Triangles and circles, points fall on a circle with radius P and the given point. The points fall on a circle. Candace said the points fall on a circle with radius of P and the given point. I like that comment. A and A prime are the same distance from P. Yeah. Sorry, like I said, I'm not very good with
It's just because they have lots of thoughts.
I know. I'm not very good with chat. You have to forgive me because I'm slow to keep up with it. Okay. Oh, I'm seeing something about perpendicular bisectors, a line connecting corresponding points. Okay, lots of observations. The circles are concentric. Oh my goodness, the circles are concentric. Yeah, I love that. Portion of the circumference traveled on each circle is the same. The portions. Oh yeah, I like that too. Anyway, gosh, I could read all these and talk about every one of them.
We could go all kinds of directions.
I know, and ask you all lots of questions. I got to remember, I'm not in class. When in class, I can keep my students late. I can't keep you all late tonight, so I got to stay on track. So my students did exactly what you're doing now. They brainstormed observations. And then you can probably imagine what I asked them to do next. I asked them to write a definition. And the definition should start rotations, move, points, blah, 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 blah.
Dot.
Yeah, dot. You fill in the blank. Now, if it's okay with you all, I'm not going to ask you to put your definitions into the chat box because I need to watch time, and I really want you to watch this video if you don't mind. So you know where this is headed. Students take the observations and then they try to write. I mean, think how powerful this is, you all. They're writing their own definition for a rotation. Yeah, they didn't know a definition for a rotation. They knew what a rotation felt like, maybe looked like, but they didn't have a mathematical formal definition for a rotation. So this is an amazing thing that they're doing here. Okay, so let's watch the video and then we're going to do exactly the same thing. We'll watch the video, think about the students, what they're saying, think about what you're thinking, and then you'll have an opportunity to talk again in a small group. How did you find the angle of rotation? The angle measure?
Connected A prime to our point, let's call it P, and P to A, or whatever the corresponding points are. And then we put our protractor here and found our angle.
Now, what if so you did A to P to A prime. What if you did B to P to B prime? What do
I
you
like,
think?
it's the same.
You think it'd be the same?
Yeah. For everyone.
Now what I want you to do is I want you to construct some circles. So the first circle I want you to construct will be centered at P. And I want it to have a radius of PA. Centered at P. Centered at P and have a radius of PA. Yeah, so if you could construct that. No, not with that one. I promise I didn't. Yeah. So I'm asking you to construct circles. It may or may not fit, on your paper, but yeah, that circle looks great. Once you do that circle, I want you to do another circle centered at P, and this time with a radius of P.
I just love watching you go right through the circle.
What do you love watching?
I love watching you go from point P to point D and they go right through D prime.
You like that?
Yeah, it's great.
Yeah.
Okay.
Kind of nice, isn't it?
Points along with circles with radius.
Yeah. You're just bringing.
P to its corresponding points. So, okay. That's crazy, Amy.
So you want to say something about the fact that points along the circle. So the circle has a center of P, and all the corresponding points lie on the same circle with the radius of P to correspond.
Yeah. So these are P. So, and this is our radius. So the end of the point, this is new points. So this point,
Mm-hmm.
along circles using angle rotation and the radius of corresponding points.
So the radius from our center of location to
What's one thing you know about the circle? Do you know the word for circles that all share a common center? You may not know this word. Yeah, concentric. I don't know. What do you think about that word?
With radii, point, and
Where is the center of rotation in that statement? What is the center of rotation? Yes. So do you want to put something in there that acknowledges that? I don't know. I feel like you addressed the angle, right? And that's one parameter of a rotation. And the other parameter of a rotation is the center of rotation, right? And I don't feel like that's explicitly addressed. Do you think it needs to be?
I feel like I would feel better with it.
Okay, where do you want to put it? How do you want to put that in there?
I probably would say something like this, I don't know how to, I mean, that's the same point. I think something like this. Just in another sentence to say the center of location to say the center line.
I think that's fair. Yeah. Yeah, I understand that. But I think we can, you know, this is our definition. We can make 2 sentences if we want. Yeah, I like that. I'm kind of with you, Simona, like just acknowledging something specific about that center seems to be important. Okay, Megan, give me one more read of it.
Rotation through points along concentric circles using one angle of rotation in the same direction. The center of rotation is the center of.
What do you all think?
I like it. Yeah, I like it.
Now, before you put that up, just like over here, I kind of, I wanted the word connecting in there. That was a little picky in a way. I want to be, you go back over here, sorry. I want to be a little picky. I'm going to add one word and you all tell me if you think it makes a difference or not. This is really picky. The center of rotation is the center of the concentric circles. Do you understand why I would want to add that word in there? Yeah. Not just any concentric circles. No, these concentric circles. Yeah. Perfect.
Okay. All right. Am I still sharing my screen? Okay. All right. Thank you. Oh my gosh. I've watched this, you know, a few times now, and I just fall in love with them all over again. Right. And they're thinking so hard about this and really trying to come up with this definition. And do you notice how carefully they're thinking about the words that they use? Yeah, they're thinking carefully about the words, attend to precision. And at the end, you know, I said, I feel bad when I interrupt them almost and say, well, I'm being really picky, but I want the word the in there. But you know, when I look at that, when I'm in the moment, I feel like, oh my gosh, I'm being picky. But when I watch back that video, I'm thinking, that's an important word in there. You know, and I think that if we want our students to attend to precision, we have to attend to precision as well. We have to be careful about the words we use as well. So anyway, in the moment, I feel like, oh, I'm being really picky. And then I'm thinking, no, I'm not being picky. I'm attending to precision. So that's good. We're going to, here's the definition. If you're going to have a couple of minutes to talk in your small groups, if you want to snap a picture of this definition, you might want to snap a picture. I should have said that for the last one. You can refer back to it in your small groups. We're not going to have very long for these small groups, maybe 3 minutes. So use your time well, and we'll talk after. All right, I think we might be back now. I think we're all back now. That got, you know, I don't know, what was that? 3 minutes, not long enough. Sorry. When I was I went to a breakout room, and the conversation mostly in that breakout room was about questioning and how questioning can really help move a lesson along in a way where that productive struggle that came up in the chat box was, or in the chat was, where that productive struggle is really encouraged, right, and facilitated. You know, if you watched that clip and that's one thing that you saw, I hope that was a good thing, and that was something that you might think about is questioning, and how that might play out in your lessons to encourage productive struggle, and to encourage your students to think deeply about the mathematics. Oh my goodness. Okay. So this is a point where I get to just say a big thank you. Thank you all for being here, and thank you all for thinking about the math, and thank you all for thinking about transformations, and thank you all for watching my beautiful, awesome students as they thought through the lesson. it's my pleasure anytime I get to do math, and it's my pleasure anytime I get to talk about math and talk about my students. So thank you. I'm grateful. I appreciate your time tonight, and I think Dee probably wants to say something.
What I wanted to say was one of the things I loved, I popped into a couple of breakout rooms, and we have folks here, as I said earlier, from kindergarten to calculus, right? And you guys were pulling different things out that you noticed, different ways that you could even take this 8th grade high school activity and pull out your grade levels math. So I heard conversations about 3rd grade math and 4th grade math and 5th grade math and some middle school math in there. And so I want to make sure that you guys remember that you can see your kids, your students in activities that don't necessarily say your grade level on it. Look there, look for those opportunities, give your kids opportunities to explore, to really explore and be mathematicians with you. Thank you all so much for staying late on a middle of the week and doing big kid math with us. I love it. Thank you.
I want to give a plug for our masquerade party. So that's a sheer time where we're just going to come hang out. And so I hope you'll find time to join us. So see you at the masquerade party.